Hello there, I'm Pooja. Welcome back to Periodic Chemistry. At the end of this video, we will be able to solve numericals that come under Galvanic Cell. If you're new to my channel and haven't subscribed yet, please subscribe and hit the bell icon to get notified whenever I come up with new videos. Let's start. In my previous video on Electrochemistry Part 5, we have seen various formulas for cell potentials and standard cell potentials. If you haven't watched that video yet, I request you to watch that so that you can have a better and clear understanding of this part. Here we will be solving numericals to calculate standard cell potentials. Let's start. Let's solve fifth question under question number 2, Maharashtra State Board 12th Standard Science textbook. Here we need to calculate standard cell potential for the reaction. The reduction potential of each electrode is also given. Let's see the solution step by step. Given reaction is 3 Ni atoms plus 2 Al plus 3 ions giving 3 Ni plus 2 ions plus 2 Al atoms. And the reduction potential for nickel is minus 0.25 volt and reduction potential for aluminium is minus 1.66 volt. Whenever it is not mentioned that it is a reduction potential or oxidation potential, we will be assuming it as reduction potential. Formula to use will be of E naught cell is equal to E naught reduction cathode minus E naught reduction anode. E naught cell is nothing but the standard cell potential for the reaction. Now let's write the two half reactions, that is reduction half reaction and oxidation half reaction. There is no need to write these oxidation and reduction half reactions because we already have the reduction potentials. But I have written it for the clear and better understanding. We can write these reactions by looking at the equation where nickel is undergoing reduction and aluminium is undergoing oxidation. This can be also confirmed from the reduction potentials because we have seen that reduction potential of cathode is always going to be greater than that of anode. And we can see that reduction potential of nickel here is minus 0.25, which is greater than minus 1.66. Therefore, it is confirmed from both the reduction potentials and the reaction given that nickel is a cathode electrode and aluminium is an anode electrode. Now let's plug the values in the equation. E naught cell is equal to minus 0.25 volts minus 1.66 volt. After doing the addition and subtraction, we get E naught cell as 1.41 volts, which is a final answer for the standard cell potential for this reaction. Let's solve another example of a similar type, fourth MCQ from the same textbook. Here also we need to calculate the standard cell potential for the following reaction. Here the reduction potential of only one electrode is given. Let's see how to calculate the cell potential for this. Given reaction is H2 plus 2Cu plus 2 ions giving 2H plus ions plus copper solid. And the reduction potential for copper is 0.34 volt. It is a standard reduction potential. We will be using the same formula for cell potential. Again, I have written two half reactions, that is oxidation half reaction at anode and reduction half reaction at cathode. We need to remember that the reduction potential for H2 is 0.0 volt and it is taken as a reference electrode. Now, it is also clear and confirmed that electrode potential of copper is greater than that of hydrogen and therefore copper will be an cathode electrode and H2 will be an anode electrode. We can confirm this from the given reaction also because H2 is undergoing oxidation as the oxidation number is increasing and copper is undergoing reduction as its oxidation number is decreasing. Now we just need to plug the values. 0.34 will be cathode because it is a greater reduction potential minus 0.0 volts. And our final answer for this will be 0.34 volts, which is option B. Let's solve Fifth question under question number 3. Here we first need to construct the galvanic cell and then we need to calculate the cell potential or the standard cell potential. We have seen about the construction of galvanic cell in my previous video. We can revise it in this part as well. The given terms are the electrodes, cobalt plus 3 ions in cobalt electrode, and the standard reduction potential of cobalt is 1.82 volts, while Mn plus 2 ions with Mn electrode and standard reduction potential of Mn, that is manganese, is minus 1.18 volts. Formula to use will be the same, that is E naught cell is equal to E naught reduction of cathode minus E naught reduction of anode. As we know that cell potential or the reduction potential for cathode is always going to be greater than anode, therefore we can tell that cobalt is an cathode electrode and manganese is an anode electrode. We have seen this short notation LONE in my previous videos, where LONE stands for left oxidation anode negative, and hence we will be writing manganese to the left hand side because it is undergoing oxidation, and cobalt will be to the right hand side because it is a cathode electrode or undergoing reduction. Now let's plug the values in the equation. 1.82 volt minus 1.18 volts, and we get our final answer as 3.0 volts, which is a standard cell potential for this reaction. So even if the cell representation is not given, we can construct the cell by using the standard reduction potentials. We can decide which is going to be an anode electrode, which is going to be an cathode electrode, and then we can find the cell potential for that reaction and also determine its spontaneity. Alright, so this was all about this part of electrochemistry. For further concepts, you can watch my other videos and my previous ones. Guys, please give your feedback so that I can improve myself and I can come up with new videos like this. Don't forget to hit the bell icon, like, share, subscribe, and comment. Till then, thank you and stay safe.